The next talk with us, we have Paolo Insogna, right? Awesome, Paolo Insogna. He's a Node.js core member and staff developer, experienced engineer at Nearform. We had some amazing experience in the past with people from Nearform, so we have really high expectations from Paolo as well. He's been, as said here, a core Node.js developer, meaning he was contributing code to the actual Node.js code base. So he has seen it from the close-up. I mean, you could have all seen it because it's open source, but probably didn't. Like most of us just use what's given to us. So he will give us the story from behind the scenes, and specifically we'll dive deeper into how Node.js protected itself from time-based denial of service attacks, which is like probably one of the most common attacks out there that happen, especially like on exposed APIs. If the talk description is correct, he will talk about the slow lion and specifically how...
Slowloris.
Sorry?
Slowloris.
Slowloris?
Yep.
Slowloris, sorry. I know it was some animal. And lorises are usually slow, so that's redundant.
Yep.
A slow lion would be something weird.
Yep.
Yeah, so he'll talk about Slowloris, which is basically a denial of service attack, which happens slowly over time with attack you by not attacking you, or with really small amounts of data. Over long periods of time, so it's quite interesting, and I'm personally really looking forward to hear this. Paolo, the floor is yours.
Yep, thank you. Okay, so the tale of avoiding time-based DDoS attack in Node.js. Let's start up front with a very bold sentence. Sometimes your worst enemy is slowness. Now, don't you believe me? Bear with me, I will show you how. First of all, let me introduce myself. As Nicola said, I'm Paolo. I'm Node core member. I'm also a co-founder and principal architect at Orama Search, which is a new company which is changing the search engine industry. And I'm also staff developer experience engineer at Nearform. You can find me my website, which is being redesigned, so skip it for now. There is my Twitter handle and my GitHub handle. And that little tiny blue dot is where I come from in Italy, which is called Molise. It's the smallest region in Italy, so small that the rest of my country pretend we don't exist. They joke with us, they say, you don't exist, we are 19 regions. Don't ask me why, that's their fun. Now, a brief talk about Nearform, which is the company that has sent me here in Belgrade today. Anyway, lovely country, lovely city. We are a very globally remote professional services company, 300 people and counting. This is slightly outdated, I should update it. And if you use Node and NPM, another bold question, you cannot escape from us. 1 billion downloads per month, and we have 8% of the NPM modules. I'm sorry, that's how it happens. Sometimes it's our fault, but that's how it is. Now, first of all, we have to understand what is our problem. Now, what do we use every day? We already reserve our ticket online, we use our phones, we use web application for literally everything. And each day we add the new things that was done analogically and now it's done digitally. That's how future works, that's how technology works. The biggest issue here comes that in the past, things were harder to bring it down. Now this application, we are all developers, we know about this, are very fragile. And this application cannot go down. If they go down, the mess can be small or very big. Think about if Facebook goes down, then we are forced to call our friends by phone. That's fine, probably, right? We can live for it for a couple of hours before, freaking out. What if our telemedicine application goes down? What if our bank goes down? Or our missile defense system goes down, for instance? We are all in very huge danger. We jeopardize our ability to stay alive and do whatever we do and we need every day. So this application cannot simply go down. Which brings to the biggest point. We are all vulnerable. That's a big problem that people don't understand. For instance, in my city, I don't have any tech friends. So all my friends are not non-technical. My wife is not technical. Nobody else in my family is technical. So they don't understand the risk of the society we are living in nowadays. Because we all know that applications are very sensible and sometimes are not written in the proper way due to lack of time, due to lack of, I don't know, experience or budget. Sometimes we rush out. And if we sacrifice performance, this is a huge problem because these applications are vulnerable. And there is also one thing that people tend to forget. For any person that you hire for security, consider that in the world there exist 100 other smarter people that are trying to mess with your application. That's the truth, unfortunately. There are always people who are trying to outsmart us and bring us down. So we have to make sure that our application can be the less vulnerable that we can. For instance, we all know about DDoS. First of all, in the audience, who knows about DDoS attacks? Raise your hand. I can pretty much skip this slide then. Okay. For the one that don't know what a DDoS attack is that, first of all, a DDoS attack is an attack where a network resource is maliciously made unavailable to the intended users, purposely, not by the creators, but somebody else, somewhere else in the world. Then there is a better for the attacker and way worse for the defender version of this attack, which is the distributed DDoS attack, in which the attacking traffic comes from very different and sparse resources from the internet. For instance, if you try to kill my server, which is hosted in Italy, you will attack me from, I don't know, just naming countries, Australia, Indonesia, Brazil, China, US, Canada, pretty much everywhere in the globe, which will make very hard for me, as I will see in a bit, to counter this attack. It's very, very hard. Now, the thing is that the common belief, and I ask you this question, do you think that in order to successfully deliver a DDoS attack, you need a lot of resources? Raise your hand if you think the answer is yes. Thank you, best audience ever. Amazing, amazing. Now, let me show you what, in case of DDoS, is unreal and slightly unknown evil, which will very, very mess with your daily life. This guy. This guy is the guy that you have to fear a lot. Because I will show you how this is insanely dangerous. And it's dangerous for a reason that is beyond common sense. It's something that you will never see why I should fear this guy so much. So, for people that don't know what this exactly is, this animal is called the Slowloris. I don't know how to translate in other languages. I wasn't even not sure how it translates to Italian. I just know his English name. This is a very, very slow animal. Now, his name is after an attack which, as you might imagine, is not based on heaviness of the resources or the speed or the number of the resources, but is based on the slowness of the resources. Few things about the Slowloris attack. First of all, this is a DDoS attack which uses minimal bandwidth, close to nothing, which is a huge problem for the reason that I will show you in a bit. This attack was created by Robert Hansen, codename Snake, in June 2009. Remember this date because it will come later. And there's something I still cannot really explain. If you now go online and search for the Slowloris attack, you will just find his application on HTTP. But, and you will explain, you'll understand later why it makes no sense to me, honestly, it's very weird. This is not just an HTTP attack. Its logic might be implemented on each protocol that uses TCP and that has no other protection implicit in that protocol. To make it easier to figure it in your mind, any stateless TCP protocol, like HTTP is vulnerable to this attack. Now, why I only found HTTP resources online? Probably because HTTP is probably the most used protocol, probably, but it's not only HTTP, it's TCP-based. You can see on the right-hand side why it's so dangerous, because, and I will outline these images in a bit, but the thing is that you see how many red lines are on the bottom right. That's your problem. That's your biggest problem. The red lines on the bottom right, which are not full lines but dashed line, are your problem. And let's see why. Let's start with very, very crash course introduction to client-server in HTTP. Pretty simple, right? At the very beginning, there is a client which connects to your server, which is represented by the connection is at the black line. It will send you the request, which in this case is a solid line, which means that your request will be completed. And after some time, it receives the green line, which is the response. Now, while it's not strictly the truth, for this example, let's assume that on the operating system, each connected socket takes the same amount of network, CPU, and memory resources. You can assume it's always the same, but sometimes might not be the case, depending also on, of course, on your operating system. Now, what happens? Step 2. The first client has received the response, so goes away. And once again, just for the sake of this example, forget about keep alive. Let's assume it's the old HTTP 1.0. One request, one response, done. But this also applies to keep alive if you want to slightly improve the example. But anyway, the second client connects, same cycle, establish the connection, sends a request, receives the response, done. The second client is gone. So we get to the third client, which, once again, same loop. Now, what is the point of this? Over the time, we can assume, under certain assumption, that the amount of clients connected to your server and the amount of bandwidth generated by these clients to your servers are pretty much the same. You can assume it's a relatively stable number. Now, of course, there are spikes, but of course they go away. And at some point, you have an average number that closely represents how many clients are connected to your server, how many resources they ask for, how many resources they receive. This is an important thing to consider when you basically monitor and protect your server. Because one thing that everybody, including myself, I'm not removing myself from the equation, everybody forgets that retaining sockets is expensive. It is a very expensive operation for the servers at different level. First of all, the operating system, because until you get to your server, which can be Node, can be Tomcat, can be Apache, can be anything, before you get to the application server, you have to enter through your operating system. The operating system manages the low-level operations on your socket, physically writes on the network link, on your Ethernet card, on your Wi-Fi network. That is done by the operating system for free, so you don't have to forget for it, right? But of course, the operating system must maintain the state of the socket, which means several kilobytes of RAM. Now, on average, on Unix system is 64 kilobytes per socket. So that's a pretty high number. And on Unix, so macOS, Linux, FreeBSD, you name it, each process is baked by a file descriptor, because on Unix philosophy, everything is a file, right? And each process has a limited number of descriptor available for the process itself. Now, how many of you know about the ulimit, what it does? Raise your hand. Okay. So basically, when you start a process on Unix or macOS or Linux, your process has a configuration parameter, which is the ulimit, which is how many files you can open. Remember that files includes file on the file system or sockets. Now, by default, this number is pretty low and is set usually to, if I'm not mistaken, 1024. right? 1024. The common thing is that, okay, you can raise this number to be unlimited. You remove the limit. Now, yes, you remove the limit for your process, of course, but this does not mean that your file system, your operating system can open a limited amount of sockets. That's not the truth. Your operating system will have an hard limit that nobody can bypass. So, best case scenario, your process can take all the file system descriptor available from your operating system, your file descriptor, sorry, no? But at some point, it will fail as well, because you open too many sockets. That's it. Then, to make things even worse, let's say you still have resources on your operating system, you go to your application. Your application will do something similar to your operating system, and for each socket, we'll have to maintain some state. So once again, extra RAM. You can immediately see where this is going. If the number of sockets increases over time, at some point, you don't have enough RAM anymore, because it's not an infinite resource. It's a finite resource. And don't get started with virtual RAM, because virtual RAM is backed by physical RAM. So at some point, you stop and you fail. All this huge introduction about how sockets work is to explain how Slowloris works. And the way Slowloris works is, in a way, astonishing and beautiful, to be honest. I have to admit, it is astonishing, beautiful, and evil, because it will kill your server very simply. Let's see how the Slowloris works. First of all, the first client connects. So once again, black solid line. Then it starts sending the request. If you notice, I use the dashed line, and by dashed line, I mean an incomplete request, because the Slowloris attack will never finish sending the request. Or eventually, in slightly nicer implementation, nicer, I mean, kind to the server, it will finish the request, but eventually after hours, days, God knows when, at some point, might finish the request, but your server will be gone way before that. So, the socket is kept open and idle for no reason. That's the first client. And then he gets a second client. And you can see that when the second client arrives, the first one is still connected. So the server resources consumption increases over time. And this increase in the server consumption is steady. It's a monotone increase in the server usage. At some point, as I was saying slightly earlier, you have no resources. Your server is gone because you cannot accept any new socket, and that's it. You are in a state where you have a lot of clients open that are never finishing sending you the request, so you are not serving the data, so you're effectively not doing anything, and you cannot accept new clients, so you cannot do anything anymore. And fun fact, your server has the full RAM, empty CPU, empty network transfer. That's it. As you can see, it's a very, very weird situation because you have literally nothing to do. Which brings the simple question. Actually, I should make two slides. The first one is can we stop it? And if yes, how do we stop it? Because I was assuming that since I'm here, you know that we can stop it, obviously. But how do we stop it? First of all, for the people in the audience that are using Node.js as a production server, don't put directly in front of customers. Never. The reason being, and I'm telling as a Node core member, Node is not focused on security. There are tools which are way better to do this thing, like HAProxy, Nginx, you name any server you like, put there in front of Node. So Node can focus on the application layer, Nginx, HAProxy, or any other server can focus on protecting the upstream server. Now, staying outside of Node, what are the mitigation strategies for this? Let me be brutally honest with you, first and upmost. None of the strategies that I can propose here is 100% effective. Because there is one big problem about DDOS attack, and in this case, Slowloris attack. How do you distinguish between a legit client and an attacking client in case of Slowloris? Do you have any idea on how to do that? I accept the proposals. Yes? It's all about time. But the problem is that how do you set that time? Yes, yes. But in this case, Nadia is proposing to check how much it takes for a client to complete the request, and she proposed 20 seconds, because I'm pretty sure that in her experience, no client is so slow for your typical use case, which is true, because you know your application, which is exactly the key. In order to be the most effective in protecting your server, you have to know your application. For instance, if you know that all your application come from people that have fiber optics network at their home, I'm just over-exaggerating the analysis you can make, then yes, 20 seconds is probably fine, right? But if you think of 20 seconds, you're cutting out probably a lot of people with mobile traffic, because they have very faulty network connections. That's why I'm telling that you can never be 100% effective. Now, if you, for instance, 5% of your audience is mobile network, and 1% of these people are over a 20 seconds request time, then you're cutting out 1% of 5%, which is the error rate that you have. So you always have to choose your error rate, but this error rate, in most cases, will never be zero, will be some percentage that you can avoid to lose. Is the same idea, for instance, for you front-enders here, if there is any front-ender here. When we make a website in the past, we chose to, let's say, cut out Internet Explorer 8, because we assume nobody was moreover using that one. That was the same idea. You assume nobody's doing that, or you accept that that percentage is so slow that consider them makes no sense in terms of effort, budget, the usual factor you have in our industry. So that's the core idea. You can never be 100% accurate, but you can be pretty accurate. Now, there are two techniques that you can apply. Nadia already anticipated one. You can enforce request speed, connection speed, or time, which is equivalent because, of course, speed can be translated to time. So, as I already said, it's hard to establish when this cut threshold is legit, too strict, too loose. You have to basically monitor your server and continually iterate and eventually say, okay, I have to do it looser or I have to be stricter. At some point, you're satisfied. The other technique, which works fine for non-distributed attacks, is limit connection per IP. We all know, given also that we have cloud systems today, that if you limit my IP address, I will spawn another EC2 instance in AWS from another zone, I'm done. So that's completely useless. But as a very quick response, you can say, okay, these IP are attacking me. I will start stopping it, so I have 5 minutes to wake people up and say, please do the proper thing in a case of an attack. But it's a very, very quick response technique, which is not effective on the long term. Now, since I'm a Node core member, I work every day in JavaScript. What about Node? Before I continue, how many people are backenders here? Wow. Front-enders, what are you doing here, honestly? Okay, how many people are full stack eventually? So because, okay, makes more sense. And how many people are using Node.js on the backend side directly? Okay, quite a few, nice. Okay, from now on, it will be Node.js only, but I ask you to stay because it's going to be funny to see what happened to Node. You will learn something that probably applies to any other servers, which will surprise you a little bit. Now, there are several timeouts that you can add to Node.js to limit the scope of the HTTP request, to limit how much time they can have to send you the request, the headers, the response, the body, and so forth, right? The fun fact is that all of these things were not added at the same time. Now, for the people in the audience that don't know about Node, Node was initially created in 2009, if I'm not mistaken, or 11, I don't remember, but definitely more than 10 years ago. Now, and one thing that people don't know, because in other frameworks that's not the case, the HTTP server embedded in Node, which is the one used by any framework in Node, Express, Fastify, Restify, Koa, everyone is using Node HTTP built-in server. The built-in server in Node.js never analyzes, consumes, or parses your request body for a single reason. As you know, Node.js is very well suited for I/O-intensive systems. And in order to be effective, it tries to read as less data as it can, which means that the application will decide whether I should read the request body or not, because the application might decide that the request body is redundant for that specific request, so I don't want to lose Node.js time on that. Request body handling in Node.js is always delegated to the application server. In this case, I'm talking about the framework, in this case. And up to Node 10.14.0, which came out on 2018, so 5 years ago, Node.js had no timeout at all on HTTP requests, neither for the request, neither for the body. And there was only a single timeout for the socket when a socket was completely idle. I will come back to that in a little second. But for instance, for 10 years, because as I told you earlier, Slowloris was made in 2009, Node was completely unprotected for 10 years, at all. Then http.Server.requestTimeout was introduced. As the name suggests, it will tell you how much time do you have to send the server the request headers. That's it. Once again, body is completely not considered. Now, as I told you, there was a single timeout existing back then, which was http.Server.timeout. Previously, the value up to Node 13, the default value was 2 minutes. So the client had 2 minutes to send 2 minutes to do something on the socket, which does not mean that the entire request had to be finished in 2 minutes. It means that at least every 2 minutes you have to send at least 1 byte, otherwise I will kill your socket. That's it. But, fun fact, during the release of Node 13.0.0, which happened 1 year later, in 2019, that timeout was completely disabled. You might think, okay, this is counterintuitive, right? Why you are disabling the only timer that exists? Because that's when the serverless frameworks like Lambda, Cloudflare, you name it, anything, start to spawn out, and they need long-running connection to, in some case, to function in the proper way. So in Node, we chose to disable the timeout and trust the frameworks to correctly handle the timeout. Now, raise your hand if you believe that the frameworks did the right thing. We are experienced developers here, Fox. Nice, I love it. Okay. As you might imagine, of the 4 main frameworks, 2 did the right thing, 2 did not. Fastify and API did the right thing. Restify, Express, and Koa did not the right thing. They completely ignored the problem. So once again, we were still vulnerable to the Slowloris attack. At some point, something changed. We were aware of this problem, and there was a new timeout introduced, which was http.Server.requestTimeout. In this case, this covers the entire request, so the headers and the body. So it was a complete fix. The client had limited time to finish the request. It was active on all the release lines, but, and that's another fun fact that people don't know, it was disabled by default. As you notice, as you remember, Nicola, during the introduction to say me that I usually see the interiors of Node that people don't see, and I'm happy for you. I'm very happy that you don't see what is under the hood in Node, because if you do, you would never call set interval, set timeout, or set immediate again, because those are very expensive, and I'm even not talking about promises. Don't make me start about promises. That's another problem. But the thing is that they are very expensive. All of those 3 things are very expensive. And basically, adding a new timer for each incoming request was a costly operation that would have killed performance a lot. That's the problem. Usually, the thing is that it's not that a set timeout is dangerous and you cannot use in your application. Just do that. Do like you would have done yesterday before knowing me. That's fine. But you have to consider at the Node.js level that we consider the entire application is on, adding a set timeout would have killed the performances. So it was disabled by default. Now, the thing is that that feature could be enabled back by the user purposely for security problems. So the thing is that, are we safe now? Because I told you we have all the active release lines, which are complete protection for the Slowloris attack. So are we safe now? Raise your hand if you think he's a yes. Come on. Yes. Naive. Thank you. Thank you. No, of course it was. Of course not. Of course not. And the answer is yes, almost. Now, before I get to this slide, fun fact. I originally gave this talk the very first time in NodeConf EU 2022, last October. Now, raise your hand if you know James Nell, by any chance. Any of you? Okay, so James Nell is a long-time contributor in Node for the last 10 years. So he's a guru in Node, right? Very nice guy. He was my former colleague at Nearform. And the fun fact, he introduced me to the stage in Kilkenny when I delivered this talk. Now, before getting to the ladder, I say, James, I'm sorry, because I now outline one bug that you introduced, because it was literally his bug while he was introducing me to the stage. But actually, you say, oh, nice, I'm very happy when people solve my bug, so that's fine. It was not pissed at all about this thing, so okay. That makes my performance fine, otherwise I would be so stressed and he was just looking at me and say, you are the one. Anyway, back to the problem. First of all, this is not the bug, but the first problem is that, just I said earlier, in order to be protected by Slowloris, you have to opt in specifically, which means that you have to be aware of the problem. Now, did any of you knew about Slowloris before entering this room today? Wow, I was expecting it at 0. So you probably would have protected your node if you care about Slowloris, which is not a direct correlation. But in theory, all the rest of the audience wouldn't know that they need to protect their server from this kind of attacks. But this is not even the worst case. As I was telling, James unfortunately introduced a bug. Why is that? Because he was trying not to set a timeout too often. And therefore, instead of using timeouts and so forth, in order to gain some performance, which is something that really obsesses people on Node, including myself, instead of using a timer, he chose a different approach. I say, OK, whenever I receive a new byte from the socket, I check if the timeout has done, so I stop accepting new bytes on the socket, right? On the surface, it seems a clever idea because you don't set up a timer, it's just an additional check, which is literally translated to an if statement in the C++ layer, and you wait for a new byte to arrive, and eventually say, OK, this socket has expired, I'm not going to wait longer. That's it, pretty easy, right? Can anybody see where the problem is in this approach? Yes, that's exactly the problem. Remember, the thing is that about Slowloris is that he will try to not send you any byte for the longest time possible. And if you combine to the things that starting on Node 13, the default idle timeout was disabled, and I never say that I was enabled back, which I never said that, right? This means that you might wait forever for the next byte, which is actually what Slowloris wants you to make. It's like not having any timeout checking at all, because it will never trigger in the check. Now, very straight. How we protect Node 16 and below? First of all, re-enable the idle timeout byte check. So it must be greater than 0. Okay? Set request timeout, because even this check was disabled. So also check this thing to be greater than 0. And if you want to be even stricter, also set the headers timeout to be less than request timeout for obvious reason. So you can eventually say, I don't know, 1 minute for the headers, 5 minutes, 2 minutes for the entire request, and you never allow the socket to be idle for more than a minute or 30 seconds, for instance. That should be fine. Like this. in this little snippet, you will see how to adequately protect from Slowloris if you're using Node 16 or below. First of all, the socket can never be idle for more than 2 minutes, which means that worst case scenario, if Slowloris doesn't send you a byte, every 2 minutes you kill the connection. So you have a steady rate. Second, request timeout of 5 minutes, which is way beyond being generous because, for instance, Nadia out of her mind said 20 seconds. I'm talking about 5 minutes. But again, better than nothing. And then the others timeout a minute. That are very good default configuration. Also remember that this thing will protect you from Slowloris on the long run. So your server must be able, for instance, if you say the request timeout must be 5 minutes, your server must be able to accept new clients for 5 minutes. After that, it's protected because the slower clients, like in a FIFO queue, will be killed. Okay? So 5 minutes, that the resistance. Node 18, I'm happy to tell you, that is finally safe by default. As I told you, I fixed the bug that James involuntarily introduced, in the, not a bug in the code, but bug in the algorithm used. How I did it, I introduced a new option called connections checking interval. Because one thing that will surprise you is that Node.js, in order to be fast, was not maintaining a pool of all the requests connected. So Node, at any given time, did not know how many clients were connected. So what I did, I implemented a connection list. So now we all know at any given time what is connected and at what stage of the request is. And I introduced a single interval for the entire Node application that every certain seconds will check and will kill all the sockets that have been idle, timeout, or so forth. The new option is connections checking interval. By default, is 30 seconds. So every 30 seconds, I have a list of all the requests, I scan them, and eventually kill all the ones that are currently slacking off. Basically, they're not doing anything. Also, we have safer defaults. The timeouts for the headers, the request, and the idling of the socket and be switched back since we were in a semantic version breaking change. We switched back to Ascener defaults, which means that the default node configuration now protects against Slowloris. Just for to let you know, I slightly tricked you because when I say that these things were good defaults, is because these are the defaults for Node 18. So these are the values that we chose for Node 18. So out of the blue, Node 18 gets to this value. So every 5 minutes, the request will be killed. That's the idea. And, oh, sorry, one thing I forgot. Fun fact, switching from the old implementation that was not working to a new one somehow improved the performance by 2%. I was not looking for that, but somehow it happened. So 2% more in performance. I mean, why not? I mean, this comes for free, so we finally made it, folks. That's the thing we were looking for. We finally made it. Now, take-home lessons, because we want to bring something home. Now, you all know about Slowloris now, but there are other things that I show you that you probably don't really realize, and let me outline it for you. First of all, security all the times. As I say, these applications are crucial. Now, we might think that WhatsApp, is, for instance, is not a mission-critical application, but actually it is, because if it is the only way to communicate to your granny, if you have a tech granny, then WhatsApp cannot go down. Otherwise, your granny cannot communicate with you anymore, for instance. Since we were talking about accessibility, that's another version of accessibility. It's something that we don't always think, but keeping applications up is a form of accessibility. Not on the front end, but on the back end. That's a thing. So always think about security. Which all directly brings to the third point, sacrifice performances. James, of course, didn't want to make any problem, because of course he's a very great guy. James, if you're watching, I love you, just in case. But I'm just making you as an example to tell people that if you always think about performance, at some point you might lose the vision and say, oh, just to the performance, I'm forgetting why I'm even implementing that check, for instance, in this case. And there are plenty of examples and plenty of code that I regret I ever written. So I'm not out of this equation. Again, whatever I say, it applies to me first. Don't think that I'm bragging on something. So performance can be sacrificed, especially because they can lead completely unexpectedly, because I was not looking for a performance increase, to a performance increase. How I discovered that? Because in order to land such a big feature, I have to do a regression testing in Node to check if performance were affected, and I discovered that they were actually better somehow. So I still don't know why. I haven't checked. I got improvement. I just shipped the PR. So that's fine. Sorry. And the very last one, which is important, and once again, James is a perfect example for this. He has a huge reputation. Once again, a very great guy. Could have just said, James wrote this code, I'm not going to touch it, right? Because he's way more senior than I am. I just trust him. Yes and no. In this case, I discovered that the code was wrong. I asked him, and he told me, that's messed up, fix it. So, which means that validate regularly what you do and what others do, every time. It's not for blaming people, it's to improve. So you always check what you're doing, and you see, okay, this code was fine maybe 10 years ago, it was fine when it was written, maybe it's the only last left line on a biggest thing that now is over, and now we don't need this code anymore. Remember that I'm talking about a code base which is more than 15 years old, so you have no idea what is inside there really. So validate regularly what you do or what others do, all the times. Now, I like to finish my talks with one smart quote from people. In this case, from William Safire, which is a writer, which is, never assume the obvious is true. Brings back to validation problem. And also to another thing, that a very unique skill that is usually very underestimated. Folks, whatever you do every day, whatever you do in any aspect, not just in IT, please, please, please use common sense. Sometimes you just forget the common sense, which is supposed to be normal. That's not the case. Always use common sense when you do things. So let's assume that I can be slow, I can be fast, so I can mess with you in many possible ways. Okay, so never assume the obvious is true. It's not. I'm not talking about sci-fi, but even in the simple reality. Usually reality is much worse than fantasy, unfortunately, so bear with me. That's it for me. Do you have any question? Here? Yep, Mike is coming.
All right. Yeah, it was a great presentation. How do you handle the Slowloris when you scale horizontally?
Sorry, can you say that again?
When you scale horizontally,
okay.
Node.js, because then the sessions are kind of stored in a like a shared state, right?
Yes, unfortunately, yes. There's no, as I was saying, the mitigation strategies are not effective. So you must, since you scale horizontally, there is still a single point of access. So as I was telling you, the first thing to do, put very good and focused software like Nginx, hproxy on front. I mean, API gateway if you are on AWS or whatever, which these tools are focused on protecting you from this problem so that you don't have to worry, like you were just saying, inside your application server that might scale without caring if clients are messing with you. Yeah. That's the idea. That's unfortunately because protecting a single server is hard, especially if, like a Node, is a general purpose tool. Now, Node is very good for I/O, but it's not a HTTP server. It's a general purpose tool. I could use for crypto if you're very evil. Don't do that because it's a CPU intensive operation, so don't do that for crypto. But you could use for crypto, you could use for transforming files, you can do a lot of things. So you cannot be focused on that thing only, and therefore you can assume it's focused on the thing only. That's the thing. That's common sense. Once again, that's common sense. Node can be protected, but don't assume it is. So use a tool that is specifically protected from this kind of attacks.
Thank you.
You're welcome. Anyone else? As usual, I kill the audience. Amazing. Folks, thank you very much.